Okay, well, thanks again for attending today on a lovely day. Well, they say that you should never speak about anything that you don't know your subject, and I'm on a very, very dangerous platform here because I know virtually nothing about the subject I'm going to talk about. And what I'm going to ask first is how many people in this room have actually made a comet magnitude estimate, a visual comet magnitude estimate?
You're talking about just one, so
no, yeah, just what one will do. So yeah,
one this year.
So some people have, a lot of people haven't. So all those people who haven't, in the naughty corner. I was hoping that Alan Fitzsimmons hadn't made a visual magnitude estimate, so I could have included him in the thing, but he has, so that's good.
It was Hale Bot, was it?
85.
Oh, 85. Halley.
Okay, what I'm going to talk to you today about is comet magnitudes, some history. So we're going to go back in time here a little bit, and you can see here from this slide is the reason for making comet magnitude estimates, which is Jonathan has already spoken to you about building light curves and also observing comets, periodic comets, for seeing differences in returning apparitions. But when we need to look at comet magnitudes, we need to go back a bit in time to see just how things developed. Well, one of the biggest problems about observing comets and making magnitude estimates is that they look so different, don't they? You know, you've got comets there that are gassy, you know, bloated pieces of, you know, sort of light in the sky. You've got comets there that haven't got a discernible head. You've got comets that have got a discernible head but they're embedded in a coma, and you've got some comets there like that one on the bottom right there, which is just basically a starlight point. Now what Jonathan wants you to do is to get a magnitude determination of all of those comets at different times, and it's very difficult to try and do that, and people have tried this in the past, and people are doing it now, but it's becoming less and less number of people doing it. Visual magnitude estimation methods. This is the ICQ recommendations of the various estimate methods. There's a VSS method, the in-out method. There's the standard, easy to use extrafocal method, the out-out method. You've got a modified out method, and you've got an extrafocal extinction method. These are all different ways of observing different types of comets to make the magnitude estimates. But the problem with making magnitude estimates of comets is that you need lots of different things to do it with, because you're supposed to make these magnitude estimates with the smallest possible aperture instrument, and that could even mean your naked eye. It could even mean with a very bright comet using a pair of binoculars back to front even. People have even started to use in the past reflections of comets, bright comets in the sky, in like a Christmas tree light there to reflect it off it, to reduce what the comet looks like so it looks like a star. Now this is the point, that we're trying to make a comet look like a star, or a star look like a comet. And there's all these methods there which are recommended by the ICQ if you want to make a visual magnitude estimate. And you can see here that there are a lot of different methods there, and it can be very, very confusing as to how you can get these things all together and get your ducks in a row there to make these magnitude estimates. I'm going to come back to some of the names of those people. Some observers, and here's a person in Poland who's observing 4 different comets and using 3 different methods for making those magnitude determinations. So you've got to go from one method to another using different instruments to do this. And not only that, you've got to start and memorise things like what the comet looked like before you defocused it, and what it looked like in focus, what the stars look like in focus, what they look like outside focus. Very difficult to do. In fact, I would say that there are very few visual observation techniques more difficult than making a comet magnitude estimate. Probably one of them is making a double star measurement with a phyllomicrometer, a very successful one. That's difficult. Comet guiding for comet imaging in the old-fashioned way when they used to do photography is very difficult as well. So you can see here that this guy has used different techniques on the same night. The early magnitude determination methods, you can see in observers such as the Herschels compared comet brightnesses with nebulae and deep sky objects, and you can see why they did that. You know, the nebulae that they were discovered by Herschel and others looked like comets in the sky, at least some of the brighter ones. But the problem was that the magnitudes of these DSOs and nebulae weren't very well determined. There was no method for determining them. So when you compared a comet brightness to one of these DSOs, it was still a meaningless number. It was just saying, well, it was perhaps as bright as this particular galaxy or this particular nebulae. But that was what they were working with at the time. And really, there was no real method for making comet magnitude determinations. Even Norman Pogson, the guy who developed the stellar scale, magnitude scale for used this, he sort of said of this observation in 1872 X1, I guess I should describe the comet as 3 times as bright as the cluster M80. Well, what does that mean? Not a lot. It was just a way of saying what was happening and what he thought the brightness of the comet was. So even this guy, Pogson, who was, you know, very, very sort of fundamental in, you know, this area of magnitudes, didn't use this method of comparing with deep sky objects. Not very meaningful, let's say. And if you look at what John Bortle said in his Bright Comet Chronicles, there seemed to be no reliable systematic way of recording comet magnitudes. And he says, since meaningful comet photometry didn't begin until shortly after 1900, magnitudes cited prior to that time must be considered rather approximate. And I think that's a kind way of saying they were more or less useless. And I'm pretty sure that John doesn't really use any magnitude estimates in his analysis that was prior to 1900. Is that right, John?
Not so far, but provided observers are consistent amongst themselves,
yeah,
it doesn't matter if they're approximate.
Okay.
When you average them out over time.
Right. Well, the turn of the last century, and when the Comet Section was formed, and we had Denning as our director, and his interest was really in discovering comets and also cometary orbits and meteor showers. So, turn of the last century, comet research concentrated on cometary orbits and solar system dynamics, and a few researchers such as Halley and later Bobrovnikov, and these names you'll see later on, and Savezievich, and these people with foreign sounding names, it's really difficult to overcome.
Yes, Mr. Buczynski.
We're engaged in comet magnitude studies, and these people were the first people who really wanted to find out, you know, about comets as they came through the inner solar system and try and make some sense out of the brightness of these comets. So these three guys over the next sort of 60 years were the main comet researchers, professional researchers of their day. Well, where did the modern method begin? Well, we've got to look back at the discovery of a comet in 1882 F1, and there were some magnificent comets about in the 1880s. There was, if you go back to 1858, actually, in Donati's comet, and look to 1900, there was some really fantastic comets. Well, this particular comet, Comet Wells, is a very important comet, and it was discovered at Dudley Observatory, Albany, New York, by a fellow called Charles Wells, and he used this 4-inch Alvan Clark comet seeker, and you can see it was a nice bright comet. In fact, it was a naked eye comet, and it was well observed by all over the world, really. And I wanted to find a picture of Charles Wells because I quite like comet discoverers and I like to look what they look like, so I searched for a picture of Charles Wells and came across a picture of him, and you can see which one he is there in the centre. He's a man with the hat and the moustache. Actually, this is a picture of his graduation from whichever college he came from at that time. And although we found a picture of him which had his name in a list, there was no key. So he's in there. But there's some magnificent hats there, isn't there? You know, and these people don't look like they've just left school, do they? You know. But anyway, that was Charles Wells. He's in there somewhere. And it's quite an interesting story about him, actually, because he was taken on by Louis Boss of the Dudley Observatory simply because, as an assistant, because a lot of the other observatories around America at that time were discovering comets. Barnard and Brooks and Swift and that were observing and discovering comets, and these people wanted to find a comet to give their observatory some status, and they hadn't discovered a comet since 20 or 30 years earlier, so they asked Wells to join them in a search, and luckily enough within a few weeks he discovered a comet for them, and it was his only comet, but it was a good one. Comet Wells was an important comet. It was the first comet where sodium was actually recognised in the spectrum of a comet. And these guys who had an observatory at Dunnet, which is just along the coast from me towards Aberdeen, Ralph Copeland and Oswald Lossey, used the spectroscope on the 15-inch refractor there, which was at the Dunnet Observatory, and they observed Comet Wells and discovered that the lines of sodium in its spectrum. Very important comet because it was the first one that the sodium ever been seen in. But as far as magnitudes go, we need to go to this chap, and well, not actually this chap, because he was responding to another chap who was called William Backhouse. Now, you may have heard of William Backhouse. I'll come to him in a second. But Backhouse wrote a note in the Observatory magazine saying that about the relative brightness of comets, and particularly Comet Wells. And he says there that except in the first observation of a great comet of 1882, which was made in bright twilight, the observed magnitude is of the whole of the head, not just of the nucleus. Prior to that, people were making magnitude estimates and just describing the nucleus, but what they weren't describing was how bright the whole of the comet was. And he says here, the comparison of a diffuse mass with a star is of course difficult, but when the instrument is put out of focus very much, the estimation cannot be far wrong. So this was the very first person in the literature to describe a method of comparing stars with comets so that they could get an estimate of the magnitude, and this is very, very, very important. And he says he tried this, and George Knott, who was a founder member of the VSS, the BAA VSS, said that he's tried this out on Comet Wells, and on throwing the telescope out of focus found the light of the head of the comet to be equal to of a star in the Bonadeur-Schmusterung, and on the same night, with Oppergrasses in the same way, he found the light of the comet to be slightly brighter than this star, and he was able to make a magnitude estimate that was tied to a particular star, and therefore it was quite reliable. And so George Knott made that observation and published it. But when we look at Backhouse, and this is Thomas William Backhouse, we find that he was a very famous observer of his day, a very assiduous observer, and a very diverse observer in the type of objects he observed. And you can see there he was born in Sunderland. His family had a bank, the Backhouse Bank in Sunderland, and it was eventually taken over by Barclays. And he had his own observatory there at his mansion in Sunderland, where he observed from. T.W. Backhouse. He used his 4-inch Cooke refractor at his observatory there, and you can see that conical shaped dome where he had his telescope, and he made observations from there, and also from a lot of other places he travelled, because he must have had some sort of portable instrumentation. He didn't carry this Cooke refractor everywhere with him. Well, let's look at Thomas Backhouse. He was the first person actually to report observations of Noctilucent Cloud. And just look at what else he did. He was well educated, independently wealthy, devoted his life to observation and cataloguing of astronomical and meteorological phenomena. He's publications were in all sorts of professional publications. He produced his own West Hendon House Observatory circulars. He included a wide range of topics, including Noctilucent Cloud, which he was the first to report, the green flash, the aurora, the zodiacal light, variable stars, novae, meteor, comets, structure of the universe. And it's worthwhile looking at all his papers because he was, you know, quite a wide-ranging, and he was the first person to call attention to the zodiacal light opposite the sun, the Gegenschein. I don't know whether anybody has seen the Gegenschein. I never have. Anybody in this room? Yeah. Nice one, John. Antarctic, we need to go to watch that. A similar achievement was his observation of nebulosity in Merope in the Pleiades. So he was a very wide-ranging observer and very assiduous as well. And he answered Knott's letter in the observatory saying that he had also observed Comet Wells on that night that Knott did to make that magnitude estimate. And he gives this here, this table of brightness, which is in the next slide, which gives the observed brightness of this comet measured in terms of stellar magnitude to which the total light of the comet was equal. First two columns, blah blah blah, and you'll see this in the next slide. So he was making observations on a regular basis of comets like this and publishing them in his West Hendon House Observatory bulletins. And you can see there the second one down on the right hand side there, with field glasses very much out of focus, comets much brighter than that Star Virginis and much brighter than A Comet. So he was making a magnitude estimate determinations using VS step methods. And this is really what comet magnitude estimates, how they're done today. For the next 60 years or so, comet observers started to use these extrafocal methods to make comet magnitude estimates, and you can see some of the main players over the next 60 years who were main comet observers: Pickering, Barnard, Beesbrook, Niesland, Bobrovnikov and Vesivetsky there, and also Albert Jones, who died recently. These people use this extrafocal method for making magnitude determinations and set the system in place that is now accepted use. But it was a BAA connection actually that firmly established the systematic extrafocal method as standard. In 1942, W.H. Stevenson, a very famous BAA observer, published a paper on comet photometry in the journal, and in this he described the method of extrafocal observations of comet brightness to compute comet magnitudes using the VS step method. His knowledge of this technique was no doubt known to him from his association with contemporary observers such as T.R. Phillips, who was observing at Headley Rectory in Surrey, and also T.W. Backhouse himself, because their observing lives overlapped. And so for many years Stevenson was using these extrafocal methods to make the magnitude determinations, because he'd learned of this method from people like Backhouse and Phillips, who were also doing a similar sort of work. So from the 1960s onwards, many international groups, mainly amateur, were the most prolific comet observers, as Jonathan has said, used extrafocal methods in comet magnitude estimates. In the 1970s, Comet Kohoutek and Halley in the 80s, when Pro-Am coordinated programs were in operation, standard methods were essential and extrafocal methods were adopted for these studies. So, the standard method is the Sidgwick method, and that's the one that's usually quoted when people write their visual magnitude estimate and send it in. So what's he got to do with it all? Where did he muscle in at? Well, Sidgwick, as many of you may know who are aficionados of old astronomy books, published two amateur astronomy Bibles in the 1950s. And in this he described the extrafocal method, and that's a picture of John Benson's Sidgwick. And he says that this was how to make comet visual magnitude estimates. Observe the comet, memorising its brightness and angular size, rack out the draw tube until the images of the field stars are the same as the focus image, attempt to find one or more nearby stars of nearly possible the same altitude as the comet, and the brightness of whose expanded image matches that of the comet. If their altitude is much different that from the comet, a correction for atmospheric absorption needs to be made. take the position of each comparison star, whether off your circles or the chart as used then, and if it's brighter than 9 it'll be in that Draper catalogue. But with faint comets, the difficulty of obtaining magnitudes to the comparison is a source of problems, and method B will have to be used. Method B, number 3, says, still carrying the memory of the comet's brightness in mind, swing the telescope to the North Polar sequence, find a star basically that's of a known magnitude and compare it with that. That sounds to me like fraught with danger. But it's what was recommended, and it is the standard method. And although we've got better comparison stars now, so you don't probably need to swing to the North Polar sequence, that was what Sidgwick said. A critic's review of Sidgwick's book said this: Stevenson made a pointed comment concerning these two books in his obituary. He wrote and stated, it was remarkable for the fact that they must have both been written largely from the armchair. From account of John's life given above, it is clear that the amount of telescopic work he did himself could at the best been fairly limited. So it's obvious from this statement that although Sidgwick had written it up, it wasn't really Sidgwick's method, although it's described as Sidgwick's method now. So, to conclude, Sidgwick's books and his description of observing methods were read and adopted, and the in-out method is now universally known as the Sidgwick method. But he never claimed any credit for inventing the method, but he never acknowledged where it came from in his book either. This was most likely Stevenson's 1942 paper. However, we can trace the method back to Backhouse in 1860s, and in his West End and House Observatory bulletins there's observations of comets which show that he uses this extrafocal method, and he was the first one, the very first one to use this method to make comet magnitude estimates. And in fairness, his name should be appropriately attached to the method, although now there's 3 or 4 people who've got their names attached to this method. But it was Backhouse who was an extraordinary observer who deserves much more credit than he receives. So the next time you're out making a comet magnitude estimate, whether it's a naked eye comet that or a faint comet, give a thought to Thomas William Backhouse of Sunderland, as he was there first. Thank you very much. 3 minutes to go.